So good afternoon. My name is Sam Peng. I'm a technical team lead from Custom House Global Foreign Exchange. I'm presenting you this practitioner's report. My colleague Yin and I work together. Anti-corruption, a domain-driven design approach to more robust integration. So in the next 20 minutes, I'm going to share with you our experiences integrating the company's next generation of trading and management system with a legacy back office system. I will show you how the two integrated systems became so intricately tangled and caused serious maintenance issues, and how the complexity of the integration component grew out of control and became eventually unmaintainable. I will then describe our solution of redesign the integration component as an anti-corruption layer to fully isolate the two systems from each other and to effectively manage the complexity in the translation. So here's some background. Since Ying already gave a brief introduction about Custom House, so I will skip this part. 5 years ago, in 2002, our development team started building the company's next generation of trading and management system called Spot. Like most enterprise applications, Spot needed to integrate with a legacy back office system called TPS to fully support business workflow. While Spot is a multi-tier Microsoft.NET enterprise applications built with object-oriented technology, TPS is an old-fashioned Microsoft FoxPro application based on tables and records. Yeah, and our experiences with integration, corruption, and anti-corruption since began. So we started with a very straightforward design for the integration. To centralize the data conversion logic and the cross-platform communication details, we built a component called TPS Export as a gateway between Spot and TPS. So when the currency exchange transaction is booked through the Spot system, information is sent to TPS through the TPS Export component. So this diagram shows the dependencies between the Spot domain layer, the TPS Export component, and the TPS system. And this piece of code intends to show you how Spot domain layer communicates to TPS system through the TPS Export component calls. Because there are many different types of information Spot needs to communicate with TPS, I will use one of the most important type in our system, order, in all the examples in this presentation to simplify our discussion. For instance, when the currency exchange order is booked in the Spot system, the book order method, which is defined in the Spot domain layer, is invoked and passed with the Spot order object. The book order method performs all the necessary steps to book the order in the Spot system, and then it communicates to TPS by calling into the TPS Export component. So it first converts the order object into a generic data structure in the form of .NET dataset, and then it passes this dataset into a public method exposed from the TPS Export component. And TPS Export, when receiving this request, will do further translation and processing, and then it communicates to TPS and send the information over. So the initial design had worked for a while. However, as both Spot and TPS evolved to support new business features, 2 years after the first release of Spot system, the integration became a heavy burden to us. Developers found that translation logic between the two systems very hard to understand and maintain. Our QA team considered this TPS Export the most unstable part of our whole system. It's buggy, it's brittle. Besides, adding any new feature to Spot, which required to extending the TPS Export, was risky and time-consuming. And the tasks related to TPS Export were consuming nearly 30% of our total development effort. So the situation was not good, and the team had to understand what went wrong with the initial design and implementation. So we have to find out major causes to all those problems. So then we had identified two major causes. The first one is spot domain was highly coupled to the TPS export, and then the complexity of translation grew out of control. So to explain how spot domain was highly coupled to TPS, I will show you two code examples here. You have seen the first example earlier. It's about how spot domain layer send the spot order object into TPS system. You will notice that spot domain, in this case, book order method, knows a great deal about TPS export. It knows how to communicate with TPS export, when to call TPS export, and what to send to TPS export. It's also responsible to initiate all the TPS export operations and push the information from spot domain into TPS. Next example, which is a worse one, it shows a spot domain, core domain object, bank deposit, which is similar to the spot order. It had a member defined called TPS file. The type of TPS file is defined inside the TPS export component. So this example clearly shows that the TPS export knowledge had deeply corrupted into the core spot domain and created tightest coupling between spot and TPS export and indirectly to the TPS system. So because spot domain was highly coupled to TPS, it caused lots of issues to us. First of all, spot domain has knowledge and responsibility not related to its main concerns and made itself more complicated and heavier than it should have been. Also, in order to test spot domain layer and the behaviors of TPS export, it's very hard because the coupling, I will show you the example back here. For example, to test book order method, the test has to set up complicated environment, cross-platform environment, so that TPS export can function properly. And also, same thing, to test TPS file, the test has to prepare an instance of bank deposit because TPS file cannot be run alone. It has to run in the context of bank deposit. So as a result, bugs, defects related to the exporting were very difficult to track and fix. Assuming spot receives incorrect information from, TPS receives incorrect information from spot, it's very hard to tell where the problem occurred. It's inside spot domain or somewhere wrong in the translation or because of cross-platform communication. And the next major cause we found with the cost or maintenance issues is about complexity in the translation. We know spot and TPS are based on very different models. Spot, let's still use order as an example. An order in spot is a kind of aggregate, contains one-to-many line items. And each line item can be associated with one-to-many contracts through a list of drawdown objects. TPS, by contrast, is used a flat table structure to represent all different types of currency exchange deals. Every record in that table is one particular type of TPS deals. So this screenshot was taken from one of Spot's web application. It shows a simple spot order with two line items. So when this order is booked and information is sent to TPS, TPS will receive a list of so-called deal records, looks like this. So as you can see, the two systems are based on very different models, and each of these models has its own complexity. The translation between such two models has to be complicated. However, the implementation of such translation was implemented at a very low level, primitive types. From this code example, you can see that the translation happens between weak type structures at a very low level, field mappings. And those field, they are defined like primitive types, like strings or integers. And also you might notice there are some technical details mixed with the other concerns. You'll see database connections, data rows, data tables. Because translation was implemented at low-level primitive data types, the translation logic had to understand the meaning of those integer strings in both contexts and to figure out the intricate association between them. Such low-level field-to-field mapping was very tedious to write and very easy to make mistake. And it also caused duplicate code across the whole component. As I said, as you notice from the code, the translation logic was buried and fragmented in technical details like data connections, data tables. The code was very difficult to understand and maintain. Note that this code example is a very much simplified one. The real code to translate spot order into the TPS records once had more than 3,000 lines. So such complexity is the worst source of confusion that caused the TPS export component almost unmaintainable. So in December 2005, the team realized that incremental refactoring would not be sufficient to improve the situation. The whole integration mechanism needs a revolutionary redesign. With help from Eric Evans and the domain language team, we started the redesign work. One of the most important design decisions we made was to redesign the TPS export as an anti-corruption layer. An anti-corruption layer, according to Eric Evans in his book, Domain-Driven Design, is not a mechanism that forwards messages from one system to another. Rather, it's a mechanism that translates conceptual objects and actions from one model and protocol to another. Such layers should fully encapsulate the translation logic and the communications, and it should fully isolate the integrated systems from each other. So to build such a layer, the team had done the following works. The first work we had done is to redesign the new TPS export interface to speak spot domain language. Let's compare the old and new interface method for booking order. The old one takes a generic data structure, dataset as input. This requires spot domain layer to convert its domain objects into datasets first. And the new interface simply takes spot domain objects as input. So with this change, we could remove every piece of code in the spot domain layer, which translates spot domain objects into datasets, and such that we can make the spot domain layer much simpler, lighter, and easier. So in the old TPS export implementation, the translation between two models was implemented at a very low level field-to-field mappings between weak-type data structures. So in order to manage the complexity of translation, we found it's necessary to discover, to abstract the implicit behavior of the TPS system. For instance, there's no particular TPS deal record type to match a spot domain order object, but conceptually, a TPS order which links a group of TPS deal records and maintains their intrinsic associations does exist, and we were able to abstract this. So we then designed the TPS order class to encapsulate all those different types of deal records and maintain their internal relationships. So having such a TPS order object, we can now translate from a spot domain objects into their TPS equivalents. So this code example just shows you a translation between spot order into a TPS order. You might notice that translation looks much cleaner now. Having such TPS order objects was proved to be a breakthrough. It enabled us to translate between objects in the models instead of playing or manipulating the weak type data structure at a very low level field-to-field mappings. And it also is a key for the developers to understand the complicated relationship associations between those records. Basically hide the complexity. So we know complexity cannot really be eliminated, but it can be hidden. And this takes each model's ability to express their data more meaningfully. So next work we did was to separate the communication details from object translation logic. So in the old TPS export design, the translation logic and some technical concerns, they are mixed together, which make the code very hard to understand and maintain. So we designed the new TPS export with 3 distinct layers, each of which has its own clear responsibilities. The first layer we call TPS Spot to TPS translator, which is responsible to translate spot domain objects into their equivalents on the TPS side. So this layer encapsulates all the translation logic between models, as I described earlier. The next layer is called TPS record generator, which transforms the TPS objects into a format can be recognized by TPS. You can consider they are in-memory presentation of those TPS records. So this transformation was pure technical. It does not involve any complicated business logic. All that had been handled in the previous layer. The last layer is called TPS file writer. It simply encapsulates all the cross-platform communication details, like platform-specific calls and protocols. So it physically connect to TPS system and send the information over. So this code example shows a spot order object is pushed through each of these layers in turn and resulting in a complete TPS export process. And we know there are many benefits from a layer design. It separated concerns and responsibilities. It made the component much easier to understand, to maintain, and to extend. What's more, if there's a bug, we will be easily to pinpoint it. The last work we did for redesigning the TPS export was to invert the dependency from spot domain to TPS export. In the old design, it was spot domain's responsibility to push the information into TPS through the TPS export component. So this burdened the spot domain layer with extra knowledge and responsibilities. A better approach would be, make TPS export make spot domain layer has no knowledge about TPS export. So we decide to use a pattern called observer to make TPS export an observer, so it will get notified when certain events happen in spot domain layer. But spot domain layer has no knowledge about the consequences of all these recent events. So we implemented this observer pattern using .NET event mechanism. As you can see that after change, the dependency got inverted. So again, let's use the order booking example in the new design. So when order is booked in a new system, the book order method no longer calling TPS export directly. It simply reads the event, order booked events. And TPS export, which already subscribed this event with the corresponding handler on order booked, get notified. The order exporting just take place. So with this change, we could remove every single reference from spot domain layer to the TPS export. And it also helped us to integrate other external systems to Spot without changing any Spot domain code. So I'm going to conclude this report. The original design, which make the TPS export as a communication gateway, is like a common practice. It worked in the beginning. However, when both systems evolved to support new features, not only did the complexity of the integration component grow out of control, it also led TPS knowledge into the Spot domain and caused two completely different model crossing each other's boundary. The key cause was that the old TPS export didn't fully encapsulate the translation logic, and it didn't manage the complexity of translation effectively. The solution is to redesign the TPS export as an anti-corruption layer to fully isolate the two systems from each other. To manage the complexity, we first discover the implicit model from the TPS system. Our experiences shows that the external system need not be object-oriented to have its model adequately expressed and discovered. So this has proven to be a key to a clean and understandable translation. The whole project, the redesign project, took a team with 6 members, 6 weeks to finish. Yet the effort was soon paid off. The integration component became much more stable. The bugs related to the TPS export got dropped down dramatically, and the quality of the overall system architecture was very much improved. Besides, subsequent projects report less than 10% of effort spent on TPS export, which compares with the 30% of the effort in the old system. Is 20% less of effort. And finally, the days when developers, they feared to approach this area of system, and they have uncertainties. They just don't know how to touch this part of system, has been long past. And I think this closes this report. Thank you.
Thank you very much. The target system, the TPS system, was that changing while you were building?
Yeah, both systems evolved separate features. That's why make this integration component very complicated. Yeah.
So how did you use tests to help, or did you use tests or sort of automated tests to help that process?
It's pretty hard in the old design because TPS expects some certain output from Spot system. We don't have layered design in the old system. In the new system, we just make sure Spot export whatever Spot should export. So we cut it somewhere. Basically, this layered design help us to test.
Was there also a need for read in the system? It looked to me that it was only writing.
Right, it's only writing because that's a legacy system. If Spot needs to read something from TPS, that would have been more complicated.
More questions?
Does the path our life has been improved after the remodeling?
Yeah.
What was that?
I have a question.
Sure.
Can you comment on the internal architecture or the internal design of your anti-corruption layer? Is it based on mapping rules, or how do you transform the object from one side to another?
How do I transform from one object to another, right? So first of all, the legacy system does not have an explicitly expressed model at the very beginning. So after abstracting this model out, so the developers had knowledge of the both system. We know the Spot domain concept. We know this conceptual model of TPS system. The translation is when you translate between two objects. So it's like the two objects have some similarities because they Spot order and TPS order, whatever they are, they're orders. So even their fields might look different, but that translation is much more straightforward than you say data column row 1 to data column row 2.
Because the two object models are relatively close to each other.
Right.
It's the same thing.
This reflects a real system, same thing, but from different angles. So.
Several organizations uses, say, application integration middleware such as BIST or WebSphere. Is that part of did you think about applying such component, or did you just basically say that, okay, we want to do it by hand? And yeah.
You mean cross-platform?
Yeah, did you consider to use some integration platform or product as part of your, say?
Yeah, I think so. Just some couple words about TPS. TPS already retired in our system. That's 2 years ago. So we have purchased a new system called Trema it's Java-based application from another company. So now we got a Trema export. So this Trema export component uses same kind of mechanism like TPS export, but it encapsulates all the cross-platform details from .NET to Java. But all these complexities are well encapsulated inside the same place.
Yep. One more.
Can you talk a little more about the tests that you wrote between the two systems? Did you have integration tests, or did you have? I know in the book Eric talks about writing tests that the other system or the target system, where those users can run, so they can say, hey, you know, the client is going to fail when I make this change, so I at least need to tell somebody else that this is. Were you able to do any of that, or anything that you learned from it?
First of all, by decoupling by freeing spot domain from understanding anything about TPS export, it's very easy to test spot domain logic. For example, to test book order, you don't really worry about any side effects because it's from this test. So that's like where it's descoped. And for TPS export, it's have multiple layers, right? Like the first layer, I can write a test, say, okay, input a spot object, output a TPS object. I don't worry about any cross-platform communication at that part. So that is well tested. And to test the cross-platform communication, I can put some testing data there, just prove this channel is clear. And
Are there more questions? If not,
thank you.